Okay folks, I just wanted to make a getting started video for my sndj tracker for SNES. So this is a Super Nintendo tracker that runs on hardware. It's been tested and it runs under emulation, which is what we can see here. Now to be honest, the key to using anything to do with Super Nintendo sound is going to be all about your sample selection. So I'm going to concentrate on that to begin with. So what we've got here is a browser tool that we can use to patch the sndj ROM. So the idea is that the ROM itself comes with some really plain, boring samples, and they're copyright free. And then it's up to you to kind of choose what samples you want to bring into your version of this ROM and patch it. So first thing we're going to do is just to grab the current build, bring it and drop it into this patching tool. And so from here, there's really four kinds of instruments we could construct using samples. There's just like a single sample pitched instrument that might be looped or one-shotted. And then as we change our pitch, it just changes the playback rate. There's a drum kit sound, which would be filled with one-shot samples. We can import sound font 2 instruments, so from existing sound fonts. We can also construct our own sound fonts if we want to. And we can also create a sliced sound. So basically take an existing sample and then just chop it up into slices and then choose which slice to play back during runtime in the ROM. So that's our four main choices that we can do, at least in terms of constructing instruments here. So the first thing I'm going to do is I'm going to clear all of my instrument slots, all my sample slots. And so here we can see we've got basically 48 slots, and each slot can contain a sample. Now it's really important here to just differentiate between the samples that are stored within the ROM and the samples that are stored inside of the current audio RAM of the Super Nintendo. So up here we've got 2 meters. We've got one that's the ROM pool, and so we've got a certain amount of budget that we can spend with our samples. And so these would be samples that would be available to every single song in the tracker. And then we've got an audio RAM budget, or an audio RAM meter, and this is only just under 60 kilobytes in size. So it's not that much space. And we kind of have to share this audio RAM between samples and if we want to use the echo effect that's on the SNES sound system. So, and here we can see, okay, from our current setup, the amount of headroom that we've got for echo is going to be 240 milliseconds. As we consume more than half of this audio RAM, you'll see this number shrink down. And so we're kind of making a choice between choosing more instruments to be stored within the audio RAM that we can recall immediately for use during a song, or do we want to use that RAM for sample storage space, for echo storage space. So that's the way to think about this. So yeah, just a bit of complexity there. So I think let's go ahead and just start off with a single sample that we can just drag in and drop. And so one thing we want to think about, and because of this RAM budget and ROM budget stuff, we want to be careful and think about where we're spending that space. And so up here under import settings, we've got a trim settings option. So here we could basically have an offset. It might be an octave, it might be 2 octaves. What that essentially means is that we're going to bring a sample in, and when we play it back on the SNES, we're going to play it back 2 octaves higher than it originally was, but the playback rate is going to remain the same. And so we're basically chopping the sample, the sample rate, we're chopping that in 4, and therefore we're saving 4 times as much space, but at the cost of audio quality a little bit. So we can kind of, that helps us save some space as well. So if we've got, especially like kick drum sounds, they're probably going to sound fine at plus 24. Some other sounds, we might, if they've got a lot of high frequency content, we might want to just have this on 0 semitones and not attempt that at all. So, okay. Let's bring in just a one-shot sound. I'm just kind of thinking, what can we do? Let's grab just like an operator patch of, or an analog patch of some sort. And all we want is a short single note. Now the patching tool won't do any trimming for us. So we have to kind of just be, lean on the conservative side in terms of time, how long this sample is. I want it to be a C3 or a C of some sort, most likely. Okay. I mean, it's not the most inspired sound, is it? But it'll do. Alright, so all I'm going to do is export that much. Mono or stereo, doesn't matter. I am going to normalize it just so it's as loud as it can be coming into our ROM. Sample rate doesn't matter that much because we're resampling it anyway. So now let's go ahead and just bring that brass to here. And here we can drop our samples in. Now I'll try it out with plus 12, and what you want to look out for is we're going to see both the pool expenditure go up and the audio RAM expenditure. And you can see that actually took up quite a bit of the audio RAM. So in this case, we might say 12 might not even be saving us enough space. Let's up this to 24. Have to clear it and then re-import it. See, it's taking up less RAM now. But the audio quality is lower because effectively we're resampling it at a lower rate because of the 2-octave offset. But still sounds fine. Let's talk about, let's say, sound fonts. So we can import our own sound fonts if we want to. And there's lots of sort of well-known sounds that you can find within sound fonts. Here's one here. And immediately these sounds are going to be very recognizable if you've played this game before. With this little preview, it'll just loop them sometimes because they're just the way that the sound would have been played back in the original game, and so just don't worry about the looping part. We can address that in a moment, but let's bring in this honky tonk sound. What a classic little xylophone sound. And again, you can see every time I'm bringing something in, it's going to consume both pool and audio RAM budget. At least for these first 8 instruments, or 8 pitch slots. Okay, so that's 5. Or should we grab? Maybe we'll grab that steel drum instead. So just with this looping, if we want to switch it from a looping mode to a one-shot mode, we can just click there. Like that. Some of these sounds, it's going to loop back not to the start of the sound. You can kind of see there, it's telling us where it's going to loop back to. Okay. So I've got those sounds. Let's also talk about constructing our own sound font instrument. So I've also got this sound font 2. It's just a simple sound font 2 editor. So we could drag our own WAV file into here. I'll just demonstrate that very quickly. So over here we've got, I've just got this like this sound here. And from here we can sort of have loop points. We can trim the start. We can have a crossfade, we can have a fade out, we can snap to 0. Automatically, because of how this is stored within the SNES, we have to align the loop to the closest 16 samples. So there might be a tension there between aligning the loop versus 0 crossing snapping. If your sample is too quiet, we can drive into it with a tanh overdrive. Here we can control some aspects of the sample and some metadata. Down here we can control the envelope and just preview it on this keyboard. Now all of that's well and good and gives us a lot of control over constructing the idea is creating a sound font with a single instrument in it that's a single sample instrument, so perfect for our SNES here. Now, okay, that's fine. Here's the cool thing is that we can also do that from within Ableton. So if we now have, let's say that same sound, I'll bring it into simpler. Let's just set up looping. I'll crop this. Again, we've got to be careful with the time. Looping, maybe just loop that last bit and we'll have some sort of sustain change and some sort of release on it. Okay, cool. So what we can do is if we store this preset, this simpler preset, I'm just going to put it onto going to move it from my user library to my desktop, just so it's in the same folder as my original sample was. What I can do then, it just makes life a bit easier, is bring that preset into here and then also bring that sample into here, and automatically it's inherited the loop points, the envelope, that sort of stuff. It's inherited it from the simpler preset. So that way we can then export. So we're basically, with an intermediary, we're able to export from Ableton instrument into the Super Nintendo. So we can export that there. And we'll just minimize this. Let's bring that sound font that we've just created, let's bring that over here. And we'll have this as our next slot. And in this case, plus 24, we can hear a lot of alias frequencies there folding back. So I'm just going to change that to maybe plus 12. We just want to be careful with the amount of space it takes up. Much more reasonable. And the actual, when we play this instrument back on the Super Nintendo, it's going to have the actual volume envelope on it properly. This is just a way to quickly check our instruments. Now I've got six slots that are filled. Let's just process one more sample that we can slice up, and then we'll create a drum kit as well. And so I've just got a vocal sample that could be nice to slice up. Okay, so I'm just going to, two things I want to do about this is just have it shorter, so just that long. And I'm just going to normalize it, so Command J to consolidate. Consolidation sets our gain, and we can then just test it out. Okay, so this little vocal sample, we're going to chop it up, and then we're going to be able to play the chops inside of the Super Nintendo ROM. Okay, great. So let's also construct a drum kit as well. So the drum kit is going to be, one-shot samples, but those one-shot samples could come from sound font. So let's grab a couple from here. Just grab, let's say, and you've only got so much space to type here. So with our samples, it's kind of useful because the tracker will display the sample name. So let's just make sure we're descriptive. Those coming in. See, we're eating up the RAM budget. So even this, and maybe one more. You know what? Let's go grab a sample that's a one shot. Not easy, is it? Let's just go with this munch. So plus 12, semitone offset. And if you want to, you can adjust the semitones here. It's not quite clear to me what's the right choice. Okay, so now we've kind of filled up all of our sample slots here, and that's within the pool tab. So if we go across to the boot tab, we can basically choose choose 8 instruments that we want to populate the audio RAM with once the cartridge loads up. Every time we load a different song, if it's got other samples on it that are within the ROM pool, those will then be swapped out and loaded up into the RAM. So this is only for initially booting up, but it could be good to have kind of some useful samples here, some useful instruments. Let's have a look how this happens. So we've got 8 instruments from instrument 0 to instrument 7. They're going to be labeled as those indexes inside of the ROM. And then we can choose, okay, what type do we want? So we might say sample, the brass one. Where do we want it to get its looping from, its looping setting? Or how many slices do we want? So I might say brass, okay. Then the honky tonk, xylophone. And as you'll see here, if you're kind of removing samples from here, this is really controlling what's happening to our audio RAM on load. So you might see the audio RAM values change. Let's do we had steel drum there. Oh, that was the sample that we created. Okay, and then here, the 7th instrument, instrument 06, that'll be our vocal bass slice instrument. And then the last one is going to be a drum kit, so drum kit 0. So let's just move across and we can have a look at the drum kit tab. So here we then instruct kit 0, which of our samples do we want to reside inside of kit 0. So I might say kick, snare, bongo, and that lo-fi sound. That lo-fi sound took up a lot. Might just try and let's just re-import it at 24. just takes a bit of... Okay. So now, using up a little bit less. Let's have a look at our slice instrument. So here, we're choosing to slice our vocals, and we might want to chop this up into 16 slices. So we can move these boundaries around if you want to, but the downside to moving them around is that the way that we reference into the memory where these slices are stored, inside of the memory, all the slices have to be of equal size so that we can just like really quickly jump into that memory point and then read back that slice. Now, if we're moving this space around a lot, that means that we have to add additional padding, which costs a little bit of memory. So yes, we can move these around, but any changes that you can make editing it out before you bring this in could be useful. But yeah, we can move that around. We've got to bake those cuts in if we want to use them. But I just want to have them straight up, 16 slices, divided equally across this space of time. You can click on the slices. Okay. So over here in the boot, kind of saying, okay, our 7th instrument is going to be our slice instrument, and we've set that slice instrument to have the vocals sample, and we're going to chop that up into 16 equal parts. Cool. Now that's pretty much all the setup we need, but the important thing here is that we're very mindful of what instruments we're using, what samples we're using, what sound fonts, what slices, what drum kits, and then we're able to construct exactly what we want when it loads up. And here, note that we still have 128 milliseconds that are spare for echo. So we can definitely use echo with this amount of samples loaded into RAM. All right, great. One thing to note, up here, we can then basically export factory settings. So a factory file would be all of your samples loaded in, everything ready to go, and then you can export that as one single file if you wanted to, and then re-import that if you wanted to. Now, that would allow you to move between ROM versions without having to reconstruct all of the samples like this. Okay, so what we can do then is we can export the patched ROM. Let's launch it up. Now, you'll notice there, just before it said press start, it didn't say press start, and so it just takes a moment to load up all those files into RAM. I might just change this to a white color. Okay. So just like with muscle memory that you might have from LSTJ, from Mate Tracker, just like with my SMS and Sega Mega Drive / Genesis Tracker, everything that you need to do pretty much comes from 2 buttons and the D-pad. So even though there are some things that you can use the other buttons on the Super Nintendo controller for, basically the A button, holding down the A button and moving with the direction pad moves us within this map up here. So at the moment we're on the song screen. Holding down A and going up brings us to the options screen. A and right moves us to the project screen. And then within the song screen, if we wanted to add a chain, we can just tap B. Then we could, with the Super NES sound chip, we've got 8 channels that we can use. Each channel is a wave-based, a sample-based channel. And so they're all equal. But if we hold down a tap to the right there, within that chain, we can then add a new phrase. And within that phrase, we can start adding our notes. Now, with our notes, you can hear that sample already. With our notes, the instrument number here, 0 to 7, corresponds directly to the instruments that we set up in our boot that are going to use up samples from our pool. This could include our kit and our slice samples. So all of that now, all that setup that we did is now paying off because we can basically choose, and we don't have to swap out samples into RAM because that loading has been done for us when we loaded up this cartridge fresh. Now, just note, if I go across to instrument, I can change the instrument number here. I can change the type. Here, I can change the sample number. So that sample number directly corresponds to these sample numbers here. Important to realize that if we change the sample number within the instrument settings, that's going to load up that sample from the ROM into the RAM. So it just takes a moment and it won't be instantaneous to change that number. See, for example, here, I'm clicking it now, and that's how long it took. It took like a second and a half or so. So you're much better off really nailing your samples and your instruments here as a starting point. And that way you'll be free to just easily switch between the first 8 instruments at least. And if you want more, you've got up, you can go beyond 8, but then the samples wrap around. So you could then choose a different sample if you wanted to. Anyway, so back here. So I'm just tapping B to add in notes and then holding down B and then left and right, up and down to edit notes. So we can just change the settings there for the envelope. Let's have a look at, let's say, adding some of the other instrument sounds here. Let's just test those out. Okay, so let's add in that's a nice little steel drum sound there. Let's say over here we've got our commands. We might put in a chord. So it will play a 3-note chord. So those 3 notes are basically coming from that track that I'm on, that channel, channel 2. And if it's playing a chord on that channel, it's going to then steal voices away from 3 and 4. Or it's going to, if there's nothing playing on 3 and 4, it's going to use those resources to play a chord. It's a bit loud, this sample. And you've got a different volume setting for left and for right. So you can pan between them. So that's that steel drum sound. So that's the instrument that we made ourselves, right? That wow sound. What else do we have? Oh, the slice sound. Okay, so let's say we've got this sort of thing. Let's add in a little honestly, I like that better as the let's add in a little beat. So I'm just double tapping B just to create a fresh chain, double tapping B to create a new phrase. So if we choose instrument 07, that's going to give us the drum kit. So just holding A and tapping B to trigger the playback of just this phrase. If I want to hear it in context from the phrase view, I can hit start. Maybe even let's speed it up, slow it down. What do you think? Yeah. So let's also chuck in that vocal slice. And our vocal slice was instrument 6. So we set up in our boot. Let's go and grab that vocal sample from the pool. So with this, it's just going to be like each slice is just a different entry here. Okay, cool. So what we can do is if we play this and we can edit the instrument while it's playing. So for example, let's just maybe mix up the rhythm a bit or the order a bit back here. We're just playing that a few times. Oh, slice instruments won't respect transpose. That's right. Okay, so let's say we've got, some interesting sample like this. Let's add a bit of echo to it. So all of our instruments allow them to add an echo option. So we can turn that echo to on. And then down here, below the instrument screen, we've got our echo screen. So this is going to tell us how much RAM we're currently consuming, which is this first line here. It's going to tell us then how much RAM we've got free for echo. And it's going to tell us how many milliseconds, how much time of echo or delay time we can implement as a maximum with that amount of RAM. So 17.6 kilobytes is going to buy us 128 milliseconds. So we just up that. Now, you'll see that as we're going up, we're consuming that RAM. We can have feedback. We can have echo level. Echo on mask is basically a bit mask, and you can turn, FF would be all 8 channels on. 00 will be all 8 channels off for echo. And so this is channel based, not instrument based. So basically, simultaneously, our echo has to be on for the instrument and on for the channel. So that kind of opens up the door, because you might not want the same instrument being played at on the same channel every time. So you could have the same sound with echo and without. So I'll just put this back onto FF, which is going to be all of our channels. So you can go above unity gain with the feedback. You heard the echo there. Okay, so below here, FIR, we've got a finite impulse response filter, and we've got 8 taps on that filter. We've got kind of presets. We can also, on the F screen, the FIR screen, we can set the tap strengths as well. So these are just sample by sample taps. And so if we had a very short delay time combined with different FIR settings, this is going to create different sounds. So kind of, think to the underground levels on like Super Mario World or Donkey Kong or something like that. You get like an echoey sound where the echo is going to have a different tonal shape to it. So that's how we can achieve that. So in this context, you can kind of see we've got presets that form the tap strength. You can hear a substantial difference. So it's worth noting, we can just edit those FIR settings here as well. And this will give you a sense of the kinds of filter that you can build with it. Just note that this is kind of an approximation of it. You can get a sense of what it sounds like that. And as I said, it will let you go above unity gain with the taps, especially combining multiple taps. So it's a good thing that we can create feedback, but just have to be careful with that as well. What else have we got? Up here, down here, so this is under the phrase screen, we can edit our kit. So here we can tell the kit's which index should contain which sample in each kit. So we can do that as well. And that's pretty much it. So that should be enough to get people started, I think, with this little Super NES Tracker. Hopefully enjoy. It's a project that I'm still, working on updating, and it'll get plenty of updates as time goes forward. Last thing to mention, we've got here file screen. We can basically save our song onto, and there you can see it's just going to use RLE compression to compress that song file, but in a 32 kilobyte space or a 64 kilobyte space, you should be able to hold plenty of songs. Depending on your flashcart that you're using this with, this might appear as a 16 kilobyte SRAM or a 32 kilobyte or a 64 kilobyte. So that just depends on the flashcart, maybe the flashcart settings, maybe your emulator settings, and so on.